time for number 10. So this one is asking to do some more integrals. So let's go ahead and take care of those. So A, we want to integrate 5 to the y with respect to y. And here's another one where this one doesn't have any u substitution, it's just knowing the rule. So this, by the rule, is going to be 5 over y divided by natural log of 5 plus c. When I integrate an exponential function, I divide by log of the number and then add c. And that's all there is to a. So since we had an easy one, that means the next two have to be harder, and that turns out to be the case. So now I have this really weird bounds. Natural log of e plus 1, natural log of 2, e to the x over e to the x minus 1. So I look at this and I say, well, derivative of e to the x is e to the x. So I could probably get rid of this stuff on top by making a u substitution, so let's try that. So let's let u be equal to e to the x minus 1. Then du is e to the x. So set up a new integral. And again, I'd like to change my bounds. If you don't like to do it this way, you can do it your way, that's fine. Both work. So if I plug in log of e to the x plus 1, I get e to the log e plus 1 minus 1. And then I remember e and log cancel. So I'm left with e plus 1 minus 1 equals e. Okay, so that means my top bound is now e. U of log 2 is equal to e to the log 2 minus 1. Same thing happens, e and log cancel. E and log cancel. So I'm left with 2 minus 1 equals 1. So now these bounds don't seem so unreasonable. Du is e to the x dx. So the top becomes a du. And on the bottom I have a u. Lo and behold, this is exactly the integral of log. Or this is, I integrate this and I get log. So I get log of u. And I evaluate that thing from 1 to e. So this is log of e minus log of 1. And now maybe you see why I chose those really weird bounds to start with. Log of 1 is equal to 0. And log of e is equal to 1. So believe it or not, the value of this integral with these weird bounds is equal to 1. Okay, c. Now take the integral of e to the x times 1 plus e to the x to the 5th dx. Alright, just like last problem, I see an e to the x and I see some more e to the x stuff. So I am going to let u be equal to 1 plus e to the x, and then let du would have to be e to the x dx. So this integral becomes integral 1 plus e to the x is u, so u to the 5th dx, like that. Okay, doesn't seem unreasonable. By power rule, this is 1 to the 6th, u to the 6th. This is power rule for integrals. That would be a good thing to go over if you're not comfortable with it, which is 1/6 1 plus e to the x to the sixth, and then plus c. Okay, and that is part C for that problem.